What are dry bulb and wet bulb temps in HVAC systems? Imagine stepping into a room and feeling the air around you. You might notice how hot or cold it feels, but there's more to the story than just temperature. In HVAC systems, understanding the difference between dry bulb and wet bulb temperatures helps engineers control comfort and efficiency. Dry bulb temperature is what most of us think of as the air temperature. It's measured with a standard thermometer that's shielded from direct sunlight and moisture. This temperature tells us how hot or cold the air is, and it's what you see on a typical weather report. When designing HVAC systems, knowing the dry bulb temperature helps determine how much heating or cooling is needed to reach a comfortable level. Wet bulb temperature is a bit trickier. It's measured with a thermometer wrapped in a water-soaked cloth called a wick. When air flows over the wet wick, evaporation occurs, cooling the thermometer. The wet bulb temperature shows the lowest temperature air can reach through evaporation alone. It's always equal to or lower than the dry bulb temperature because evaporation absorbs heat. The difference between the dry bulb and wet bulb temperatures is called the wet bulb depression. This gap tells us about the humidity level in the air. If the two temperatures are close, the air is humid. If they are far apart, the air is dry. This information is vital for HVAC systems because it helps engineers understand how much moisture is in the air and how effectively evaporative cooling can work. In practical terms, measuring dry bulb temperature involves placing a thermometer in the open air away from direct heat sources. For wet bulb temperature, the thermometer with the water-soaked wick is exposed to airflow, and the evaporation cools the bulb. These two readings are used together on psychrometric charts to analyze air conditions, calculate humidity, and design cooling systems. For example, if the wet bulb temperature is high, evaporative cooling might be less effective, and other cooling methods are needed. If the dry bulb temperature is high but the wet bulb temperature is low, evaporative cooling can be a very efficient way to lower the air temperature. Understanding these temperatures helps mechanical engineers design HVAC systems that keep indoor environments comfortable while saving energy. Accurate readings allow for better control of air conditioning, heating, and humidity levels. This way, HVAC systems can be optimized for different climates and building needs, ensuring comfort and efficiency every step of the way.